In this video, we're going to create a couple of geometric objects in a special way. Let's start off with this definition. A geometric shape constructed using only a compass, that's a compass, and a straight edge and a marker, pencil, pen, is called constructible with Euclidean tools or simply constructible. So what that means is I can use this protractor only for the straight edge. I can't use it to find a particular 72-degree angle or an 88-degree angle. Can't use it for that. All I'm going to use is a compass and a straight edge and pencil. And again, we'll call that constructible with Euclidean tools or simply constructible. Let's start off with a regular three-gon called ABC. Well, what is a regular three-gon? It's a three-sided figure, three-sided polygon, so it's a triangle, and regular means it has the same length, sides. So that's an equilateral triangle. And in this case, I'm going to call it triangle ABC. Equilateral triangle ABC. And we're going to use only a compass and straight edge. So what does that mean? I could have simply said construct it with Euclidean tools. Okay, so I've got my straight edge, I've got my compass, and it says right here, start by drawing one of the segments, AB. Then we just need to come up with BC and CA, and we'll be done. And each side has to be the same length. So what you do is you set up your compass so that the points are the same length as this line segment AB. Okay? So then you take the point, put it on one of them, A, and you mark a little arc here, like that. So all these points are the correct distance away from A. And then we do the same thing, putting the point on B, and you mark a little arc so that it crosses. So wherever it crosses, that's going to be our third point. This will be the point. Oops, this will be the point C. So then I take my straight edge and draw AC and BC. Like so. So we drew, let me put C right there. So we drew the triangle, equilateral triangle ABC, using simply Euclidean tools, which means a compass and a straight edge. Okay, the next question is, can we do similarly for a regular four-gon? And what's a regular four-gon? A regular, a four-sided polygon with the same length sides, that is a square. And I'll call it A, B, C, D as the corner points. And the answer is yes. We'll do that right now. Okay, I'm not going to write down every step, but I've already started it off for us. You draw a segment, or a ray, I'll call it, AB, and you need to extend it beyond just the segment AB. And what I want to do is, since I've already got that done, I'm going to draw a perpendicular through the point B. So I have to construct, using this, a perpendicular. Well, how can I do that? Well, set up your compass so that the distance is correct from point to point. It's the distance from A to B. And then I'm going to extend that one more time and put a mark right here. So now I've got, maybe I'll call this B prime. So what do we have here? If we look at only the segment A, B prime, B would be the what? The midpoint, because that length and that length are exactly the same. So then you open up your compass just a little bit, make it a little bit bigger than the distance between AB or BB prime. And starting with, well, it doesn't matter which side you start with, put your points of the protractor, the compass, on B prime and put a mark, an arc, over the point B. Do the same thing from the point A. Put the point on A and then construct an arc like that. All right, so where these two arcs intersect gives us the perpendicular through B. So now I'll draw the perpendicular. Like that. And now, I didn't get it exactly through that point, but okay, so now we're going to find the third point, ABC, by getting the distance from A to B on the compass, and then putting the mark on that perpendicular we just drew, right there. This point is our C, right there. Okay, so now there's multiple ways to get that final point D. I could draw a perpendicular that way, but there's an easier way. If we just note that, let's see where this is set up. Yep, that's correct. It's the distance from the length of one side. So from C, you'll put an arc over this direction, like so. All right, and then we'll do the same thing from A. We do an arc, set the point on A, do an arc there. And where those two arcs intersect gives us our fourth point, which we're going to call D. And now I can just connect A to D. And then D to C. And we have a square. It may not be exactly perfect because I may not have put my pin exactly on the right point, but that is how you construct a square using Euclidean tools. So now we have all four right angles and all four sides the same length. So the last quick question. Could we do the same with a 5-sided figure and a 6-sided figure, regular polygon, and a 7-sided regular polygon, and an 8? Could we do it for all n-gons, where n is 3 or 4 or 5, 6, 7, 8, 9, 10, and so on? Well, the answer to that is no. And in the next video, we will discuss which polygons are constructible with Euclidean tools.